User interaction is always required to extract schematic parts from 3D shapes. Either mesh cutting allows the user to draw strokes to specify the foreground and background regions. However, the user can hardly control the cutting boundaries. Cross-boundary brush allows the user to draw strokes across the design cutting boundary. However, the cut is much sensitive to a user's input strokes. We present a novel interactive tool called iCutter for cutting 3D shapes into schematic subparts. Since the user always knows where the cut should be made before he makes a cut, our iCutter tool allows the user to draw a stroke around the designed cut. The user does not have to pay much attention on how precisely the stroke lies to the exact cutting boundary. Our iCutter tool can intelligently return the design cut to meet the user's intention and expectation. Here's the algorithm of iCutter. To execute a cut task, the user roughly draws a stroke on the mesh to specify where cuts should be made. Then a set of points are uniformly sampled from the stroke. For each sample point, we compute a set of points along the normal direction of the stroke and select the one with minimal negative curvature. From this point, we compute 2 points along the normal direction and regard it as the foreground and background candidate points. We compute a harmonic field for each pair of the foreground and background points. We develop a geometry-aware weighting scheme so that the harmonic fields can reveal the local geometry quite well. Then we average all the harmonic fields and obtain a scalar field as shown here. A set of isolines are computed in the scalar field. Each isoline is scored by a metric considering 2 factors, centerness and curvature concavity. The isoline with the highest score is then selected as a cut boundary. We show some examples to illustrate the applicability of our iCutter tool. In this example, the first user draws a stroke and obtains a design cut. The second user draws a different stroke and obtains almost the same cut result. This shows that our iCutter tool is stable and is not sensitive to how the user draws the stroke. We add some noise on this mesh. The user can also easily cut out the design part by drawing a rough stroke. As the scalar field is not sensitive to the pose of the shape, the user can easily use iCutter to cut out the design part. Here's an example of using iCutter to cut out the schematic parts from a high-genus model. This is a more complicated model. The returned cutting result by iCutter is not exactly what the user expects when he draws one stroke. Then he can draw another stroke and get the design cutting result. Here's an example showing the whole process that the user uses iCutter to decompose a mesh into various schematic parts. The user just needs to rotate and view the mesh, draw freehand strokes, and immediately obtains the design parts. We tested our algorithm on a large number of models. Here shows some of the cutting results using our iCutter tool. In conclusion, our iCutter tool provides users a favorable experience on cutting 3D shapes, which embodies the motif, "What you draw is what you get." Thank you.